Hello, I'm Brian, and we're here to talk about where should I run my stuff. So, like all good questions in technology, the answer is it depends. And that's the reason there's this whole talk. So we're going to talk through what it depends on and how to how to make these decisions, right? And basically, I'm going to go through each of these, except Firebase, and talk about kind of what they are, what their sweet spots are, and what the trade-offs are, like how you might make a decision between them, um, and then some more kind of bonus stuff around how they can work together. So each of these I think of have, as part of kind of a abstraction layer cake. So at the top, things are more abstract, and at the bottom, they're more concrete. So the bottom, we have VMs, right? At the top, Firebase is a tool for people writing mobile apps and web apps where they don't want to think about the back end at all. So it's kind of all handled for you. Down one level is Cloud Functions, and it's like a really good fit for things that are primarily event driven or perhaps kind of glue. Next down, we have App Engine, and it's for thinking about kind of an entire web app altogether. Next one down combines web apps and events with containers. So you can run anything that runs in a container and serve it up on the web with no fuss. Next level down is Kubernetes engine, which is hosted Kubernetes for running whole clusters of machines, running an application or multiple applications with lots of containers. And then next level below that is straight VMs, virtual machines, run anything you want to that runs on a computer. And by the end of this, I'm going to basically try to convince you that like this is a comparatively low risk decision. Don't worry too much about like the right or wrong choices here, but still give you good info on where to start. So let's go through this, and we'll start kind of top to bottom and start with Cloud Functions. So Cloud Functions are a function running in the cloud. I guess name makes sense. And it's basically you write the function that takes some parameters in, uh, perhaps has some side effects, and returns a value. And we handle all the rest. And you write that in kind of one of a few programming languages. And these functions are triggered by an event happening somewhere else in the system, either coming in from the web or from our message queue PubSub or from cloud storage, which is our object store. So something happens in the world, and then your function gets called. That's the high level model there. And all the rest of the infrastructure is managed for you. You pay for what you use, and it auto scales up and down. So as a developer, you're thinking about what events make up your system and what the definitions of the functions are. So this is a really good fit for serverless, right? It's almost kind of fits the definition of serverless. It is a really good choice when you've got PubSub or cloud storage as a key part of your application. Anytime that you really don't want to think about the runtime environment at all, just how the pieces connect, it's a good fit. Data transformation, people don't necessarily think of that as a top level thing, but you've got information coming in on a regular basis and you need to make it in a slightly different format, that sort of thing. And my favorite is, I just think about it as kind of web glue. So we've got all these different APIs that help you do lots of different stuff. And sometimes all you need to make a system is to connect two or three of them together in a particular way, and boom, you've got some real value. So it's a good fit for that sort of thing. On the constraint side, since like you're thinking about functions all the time, it's only functions. And when you start having lots of them, it can be a little bit challenging to kind of keep track of them or debug, that sort of thing. All of the interaction is via events. So if you want to start them yourself, you have to come up with some other way to kind of poke it. And we support certain specific language runtimes. Pretty good variety, but if it matches what you need, great. And if it doesn't, you may have to look somewhere else. Okay, next level down is App Engine. So App Engine is, arguably, it is the kind of like earliest cloud thing that Google did as a developer product, kind of before we even had the name Google Cloud. And its goal is to really help developers just focus on the code. So you've got a full code base that handles mapping URLs to different parts of the code. There's a couple different data stores that you can use with it nicely, and all the rest of the infrastructure is handled for you. So you're thinking about your whole app and like all the different parts of the web, URLs that have handlers. Um, since it is, very mature thing, it has deep support for things like versioning, traffic splitting, a lot of granularity in seeing what's going on with it, that sort of thing. And I think you could arguably say it was serverless before it was cool, before that term was kind of really like in popular use. Um, as a developer, when you're using App Engine, you're really thinking about the code base, all of the code that makes up your app, and the particular web requests that come in and which parts of the code you want them to hit, what handler and what you want to do about that, as the primary things. Like that's where you spend almost all your time. And then additionally, this kind of idea of, okay, here's a new version of the code. I'd like to test that out with a small amount of the traffic, or kind of move forward or roll back afterwards. It's a really good fit for an application that is HTTPS, or HTTP or HTTPS, kind of web-driven app, for things that are kind of primarily stateless, or use one of our managed databases, and especially for scaling really quickly from perhaps very low levels of traffic to very high levels of traffic. One of the sweet spot use cases is things like kind of landing pages for seasonal events or things like that, where it doesn't get really used for most of the year and then suddenly super busy. On the constraint side, like, again, we have certain language runtimes that are kind of fully supported, things like Java, PHP, Python, Go, Node, and you really are speaking web requests, like the request response. That's how you have to talk to App Engine. Next level down the abstraction tree is CloudRun. And this is where serverless kind of really connects with containers. And, so what's a container? Why containers? Could go into a lot of depth here, but, concretely, we're talking Docker containers. And I think of them as really solving the problem you have where like software works one way on your dev environment, but doesn't work in production. And you're like, well, it worked on my machine, or that sort of thing. So basically they wrap up the program, all of the files it needs to run, maybe some data files and some stuff, into a zip file that gets pushed to a repository. And then that gets pulled down. And every single time the programs run, it sees the same initial state. So it kind of solves that problem. So containers are lovely. They let you run kind of almost any software in them. And CloudRun is a way to take anything that does run in a container on Linux and connect that to the web, connect that to the internet. And so basically you listen, for HTTP traffic, and CloudRun handles the rest of it. It does SSL termination for you. It does the actual traffic routing to the different processes. So it might run one, it might run 50 to handle the amount of traffic you have. And in fact, fairly uncommonly, it can actually send multiple requests to the same process. So if you've got a process written in Java, Go, what have you, where it can handle multiple concurrent requests at the same time, you can do that in CloudRun. And since your build on kind of like while that process is actually running, you can handle multiple requests in the same process and save money. So that's really nice. It scales up and down very quickly, and very granular billing on usage. So when you're writing something in CloudRun, you are thinking about building out that whole image, the software that runs in it, which files are there, that sort of thing. And then also it's kind of up to you to figure out how you want to build that image. So if anything from doing it as a one-off on your computer, or more likely, using a build system of some kind that then pushes the resulting Docker image up to a repository. And then when you set up CloudRun, you basically say pull from this repository and run the processes from there. And the contract is pretty simple. You look at an environment variable for what port to listen on, and you start a web server and do work. And then the other kind of constraint is that there's no local persistent storage for that process. So this lets us scale up and down, kill processes, start processes, different places, and handle lots of traffic for you. So That contract's not super onerous. Like it's not a super big deal. So that means you can run nearly any software that runs in a container and run that in this very scalable way. So it gives you a lot of flexibility. It's a really good fit for workloads that are inherently stateless, um, for things that are kind of web HTTP request response, and in particular where you have specific dependencies needs. You need to run a certain programming language. Like if you want to run something written in COBOL or Fortran and put it on the web on Google Cloud, this is going to be a really good place to start. Or if you've got really particular um, module dependencies, maybe you've got a Python module that needs a C library written in C and needs to work a certain way, this is a good place to run that. On the constraint side, you do have to think about and use containers. So it's up to you to figure out how you want to do that build. And then in addition to what I just talked about was the fully managed portion of CloudRun, there's also the same exact contract can be supported on top of Kubernetes. So you can then, anything you write to run in CloudRun can run anywhere Kubernetes runs. So that can be on Google Cloud or another cloud or on your own computers, wherever you've got Kubernetes going. So that's really powerful. Which brings us to Kubernetes. Um, and Kubernetes itself is an open source project. It's essentially a de facto software for running containers at this point. I think of it as kind of when you're like, hey, containers, that runs on my machine thing, that's a good idea. Let's do a lot of it. And you end up pretty quickly with thousands and tens of thousands of containers, and you want to figure out how to manage them. That's the problem space that Kubernetes was built to help you with. So it helps with that. It helps you insulate yourself from different physical environments of computers. And then I think it really helps with the mental model of thinking about an application instead of how the computers talk to each other. And then Kubernetes Engine is the Google Cloud hosted version of Kubernetes. So we handle the machine updates, we make it really easy to get the cluster set up and get connectivity to it, help you scale up and down, things like that. So when you're using Kubernetes, you are thinking about the logical infrastructure. And I like to think about this as kind of like the whiteboard. So when you and a colleague get together and you like start drawing lines and boxes on the board to explain how things work, Kubernetes actually works at pretty close to that level. So like things that would be a box and a line, you're going to make a configuration file that represents that, a YAML file somewhere to do that. And so you're really thinking at that level of abstraction, and it's really powerful. So, what are the programs? How do they connect? Where do they store state? How do they find each other? What are they allowed to do? Things like that. It's a particularly good fit for anytime you have a complex software setup, microservices or just like half a dozen pieces that are trying to talk to each other, and you need to run that in multiple environments. So if you need to run it in a test environment, a prod environment, and have it work the same way, or in different legal environments where you have your main instance of the cluster maybe runs somewhere, and then you need to run another instance in another country because they have specific rules around that your company needs to follow. So you can write the code and the management, work and do it in the same way in both those environments. So that's really powerful. And it grew up with containers. It's all about helping you run containers. So if you and your team is like focused on using containers and like getting the most out of them, this is probably a really good fit for that. And related to that, though, I think it's all in on containers. So it really means you need good communication between the different teams and the roles. So your dev folks and your operations folks and your security folks like all need access to the same repository, so that when there is a security patch that comes out, they can patch the same place that the development work is happening, so that it gets out to production the same way. That sort of thing. And that kind of gets into the constraints a little bit. So like you need to be using containers. It's up to you to figure out how you're going to coordinate the builds of those and how your teams are going to work together. And then there can be occasionally some challenges around licensing or certain architectures, but around licensing in particular, because it's a pool of machines, some licenses want to be machine specific. And so there's some options for doing that, but you have to do a little bit more configuration. And then, so But all of that is true of Kubernetes, like all these things, this installation and abstraction, that sort of thing. The other point I just wanted to make is that I think part of the reason anybody cares about containers and Kubernetes as a whole, a big one that's not talked about too much, is that it helps you save money. You can run more software on the same computer or virtual machine without it like messing up the other software on the same computer. Because the containers insulate them from each other. And that means you can get higher utilization, you get more work done for the same amount of money. So that's really valuable. And then Kubernetes engine itself, gets you all of that, and with more management of the cluster itself as one big advantage. And the other is, sometimes it's not clear whether Kubernetes is going to be a good fit for you, or you want to learn it, or whether it's going to work on a given project. And a managed cluster is just the easiest way to get started. You can have a cluster going in 5 minutes and then play with Kubernetes. Even if you don't actually intend to run it there long term, it's going to be way easier to get it started and figure out, whether it's a good fit for your problem. So I recommend that. Next up is Compute Engine. So these are virtual machines. And I'm going to come back to this phrase, but I like to think about it as a slice of a data center. So basically it's a computer, and you've got a certain amount of memory and disk and network and CPU. The thing that makes like our general purpose machines in particular really awesome is that you basically have a separate dial as an option on each of those things. You can attach multiple disks or different size disks to any of the size machines. You can have machines that have more memory or more CPU, depending upon the actual workload you have. So basically you don't have to pay for the part of the computer you're not using. And it makes it easier, especially for like beefier systems, to make a machine that just matches the kind of work that machine is doing. You get the most efficiency and not any more, I guess, not wasting anything. And then we do have a few specialized machine types that are extra large in either memory in particular for running things like SAP HANA in-memory databases, or for doing really compute-intensive workloads. So take a look at those. And then as a whole, all of these, they start very quickly, and we have a lot of different operating systems that are part of Compute Engine, we kind of do redistributions of that have a few extra tools in them to make it really easy to run. So that's Debian, CentOS, CoreOS, Ubuntu, Red Hat, SUSE, and of course, Windows Server, different editions. So take a look at those. And if you need to, you can also kind of roll your own distribution or build a custom organization specific version of one of these and resave that. And I want to talk about disk for a moment, because that's where I think we normally think of a VM as a slice of one computer. And, our disks and network in particular are really, you're getting a slice of the whole data center. The default disks, the persistent disks, are network attached storage, but they're on really fast networks, and the blocks are spread out across thousands of machines. So you get, most of what you would get out of a SAN for every disk. So things like you can take an image of the disk while it's running, restore that onto another computer to look at it. You can make any of the disks larger while the computer's running. You can have disks that are replicated and actually live in one region spread across multiple failure zones. Things like that really help out a lot and can drop whole parts of your architecture out, make things easier to run and operate. And then they're more than just computers. So there's this handy thing you can do where if you just want to run one VM or one container on a VM, you can just do that. And we'll handle starting the OS up and running the container and downloading it. And you just don't have to worry about it. And that's super handy if you need a really big container, for example, or you just don't want to mess with the complexity of running a larger system. And then on top of all the VMs, there's this API called Managed Instance Groups, and it lets you treat a whole group of machines as one. So you have a template for the OS disk, and there's a dial basically for how many copies of that you'd like to run at any time. And so you can say, okay, I want more or I want less, and we'll start up the VMs, handle the load balancing and all that sort of stuff, and connect them all and have that work. And then in addition, you can set that up to be automatic so that it scales based on traffic, or you can run different versions of the app and see how they're doing, things like that. And then the load balancer itself is actually also a data center level construct. So when you change the config of the load balancer, you're actually changing the configuration for the whole data center. And the same load balancers we use for Gmail and for YouTube are serving your traffic. And so it's not going through like one particular box somewhere. So it can scale up really fast, not limit, the traffic. So when you're using VMs, you're kind of thinking about everything, right? You're thinking about your software, you're thinking about the operating system, the disks you're making for that, the configuration of the machine, how much CPU, RAM, and disk, the networking, how they talk to each other, firewalls, load balancing, kind of all of it. So that's a lot, but at the same time, it gives you the flexibility to run pretty much anything that already exists. So if you have an existing system, it's probably going to be where it fits. Yeah, on that note, like it's like lift and shift, like a system that's already running, like this is probably where you're going to want to start running that. That use case I talked about for like, I just want to run a container, really handy. Also, if you have very particular licensing requirements, it's maybe bound to a particular machine, we can handle that on Compute Engine. Or if you need a particular kernel or kernel extension, or even a very specific OS, maybe even a custom OS, all of that can be done on Compute Engine. And it is where I think most people run kind of intensive databases, is running on top of Compute Engine, including like our managed Cloud SQL instances are in turn running on Compute Engine. And you can speak kind of any IP protocol network service, so any TCP protocol based network service. So it's a good fit for a really wide variety of things. On the constraint side, most of it is that you end up having to think about more, and you have to decide how to handle software updates, and the adding a new computer takes like 20-30 seconds. So there's a larger chunk of time before you can respond to new traffic. Okay, so did I answer this question of like where should I run my code? Basically, we went through this whole abstraction tree, right? Things are more abstract up top, and then kind of get more concrete as we go down. And each of them has a sweet spot. So if in talking about that, like you were like, oh, hey, this is the one for me, great, go start there. Take a look at that, maybe look at the ones next to it. But got it. Let's start there, do that. But it still depends, right? And I want to talk about a few other things it might depend on. So there's this abstraction level, there's technical requirements of the software you're building, and then there's your team. Like, what are the humans? What do they like doing? What are they good at doing? How do the different teams get along? There's some factors there to think about. So let's go into those. So abstraction, I think we kind of spent the most time on this. Basically, what are the things your team likes thinking about? What is the best fit for the problem you're working on? And that may drive you to pick a particular one of these. So think about that. Additionally, there are technical requirements for the software, and these generally pull you down the abstraction hierarchy. So if you, for example, need to use a GPU right now, that's going to pull you down into kind of the lower level items. If you need a really specific Linux kernel, that's going to pull you all the way down to VMs. So look at what your technical requirements are, make sure that they work on the service you want to use. And occasionally it may pull you down a level. Billing model, I didn't talk as much about, but basically the top half is based on transactional usage. A request comes in and it costs a small amount of money to serve that request. You get that sort of thing going on. At the bottom, we have more of while it's on, it costs money. So you're making a reservation, and even if you don't use it, it still costs money. So it's really to your advantage to use it all the way, get high utilization. So how the billing works for your software and how your organization thinks about billing, that also may affect the decision. And then also the team, if your group is entirely made up of developers who don't want to think about computers at all and want to focus on the code they're writing, you're more likely to going to be higher up in the abstraction. And if you have a kind of a multi-team group that has really particular opinions about how things should be configured and how they should work together, you're much more likely to be kind of lower in the abstraction hierarchy here. So take a look at your team makeup and, also just what you're good at, what you like doing, that may influence your decision as well. And then also just, how long has this code existed? I think generally I recommend if you're starting something new, try to start high up in the abstraction hierarchy. It's going to save you time. Um, it tends to be relatively easier to move down. It's to your advantage to start and stay up as high as you can, as long as you can. Whereas if you've got existing code, it's almost always going to work on Compute Engine. And if it's in containers, it's probably going to work on Kubernetes or maybe even CloudRun. So, likely you kind of start towards the bottom and work your way up over time. So maybe you migrate into the cloud and then you move parts of the system into other things later, things like that. So think about those things. And then when it comes to did I make the right decision? Actually, realistically, most systems are made up of multiples of these together. So it's pretty common, for example, to have it's primarily a Kubernetes-based system, but you've got a few existing apps that run on their own VMs, and you've got some glue that runs in Cloud Functions, for example. Or you might have any different set of combinations there. So that happens. It's common and normal. So just pick the right thing for each part of your system. So that's a good option there. And we have a couple tools to make that easier to do. And as you get more moving parts, they become more and more useful. So PubSub is our durable and high throughput message queuing system. So you can pass messages around to different parts of the system without them necessarily being up or about them. And Cloud Storage is an object store. It's a key value store that lets you save information so that some other part of the system or you later can pick it up again. So for the stateless parts of the system, if you're using lots of serverless, chances are you'll store things longer term in Cloud Storage, things like that. Or you may decide to move up or down these abstraction levels as you learn more about your application. So, you may start up high and then later be like, actually, this is already in a container. We're going to move it down a level so that we can get access to something a little more specific. Or, we're adding a piece to the system that has a new technical constraint, and that might pull you down. Or you might be kind of starting down low and decide you want to get some of the management benefits and to move you up a level. So we try to make it relatively easy to move up and down. Once you're in containers, it gets relatively easy to do that. It's almost always just very straightforward to go kind of down a level. Sometimes it takes a little bit of work to kind of move up an abstraction level, but that's definitely an option. And then we try to make the behavior as similar as possible between these different environments. So there's a metadata server that is available, in each of these that you can get things like security tokens from. You can log to Stackdriver and do monitoring and alerting. It's the same way, using the same code, whether it's running in any of these environments. So try to make it pretty easy to get back and forth. And that brings us back to, our high level thing here. So, these I think are, again, like the sweet spots, definitely, things overlap a bit, so you have a choice between kind of two or three of these sometimes. But I think these are like what I'd like you to remember. If you've got an app that looks like it's just a web app, think about starting with App Engine. If you've got an existing system, probably think about starting with Compute Engine, that sort of thing. And if you'd like to get some more info, here's some links and URLs to go read a bunch more. There's some quick starts for trying things out and the like. And my Twitter handle is Brian Dorsey, and feel free to email me at Google. Thank you very, very much for your time. Take care.